Very good morning. In this video, we will see about Introduction to Neural Networks in the course IT22043 Deep Learning and its Application. The main objective of this session is to understand about the nuances of modern practical deep networks. At the end of the course, you can able to interpret the fundamentals of that drive deep learning. These are the reference books we will follow in this video. This is the syllabus for Unit 2. So, what is a neural network? So, from this picture, you can see a child learns animal names by seeing various pictures, and it is related to the human brain. So think of a neural network like a super smart computer brain that can learn things just like how we humans learn from experience. Imagine you are teaching a child how to recognize animals. You show them picture of a dog, cat, a bird and so on. The child looks at each picture and learns what makes each animal different, like shape, color, size. After a few tries, the child starts to recognize animals all by themselves. A neural network works in a similar way. It gets training data, and over time it learns how to recognize patterns and make decisions based on what it has learned. A neural network is a computational model. So now we come with the formal definition for what is neural network. A neural network is a computational model inspired by the human brain, consisting of interconnected layers of artificial neurons that process data and learn patterns. It is commonly used in machine learning and deep learning for tasks such as classification, regression, and pattern recognition. So now we will see how this neural network works. So the neural networks has three layers. One is the input layer, and then hidden layer. Third one is the output layer. So the input layer where it gets the information. For example, the pixel of the picture entered in this layer. Suppose if you want the network to recognize pictures of fruits, then the pixels of the picture represent each node in the input layer. And then hidden layer, these layers do the heavy lifting. That means the neuron in this layer process the data and try to find patterns like this is round, this is red. The more hidden layers are there, the more complex things the network can able to learn. And then finally the output layer. This gives the final decision or prediction. For example, the output layer might decide whether the picture is an apple, banana or orange. So in order to decide things, first we have to train the neural network. So in simple way, this is the training process that happens inside the neural network. In order to teach a neural network, you give it a lot of examples in the form of training data. Just like the child looking a lot of pictures. Initially, the network makes mistakes, but every time it makes a mistake, we tell what is the right answer. So here it is. So the target output is our correct answer. So we are telling the network and what is wrong with that. So we will tell it the right answer, and the network adjusts itself to do the next time more correctly. So through the learning algorithm. Think of it like playing a game. At first, you might not know the rules, but the more you play and learn from your mistakes, the better you get at the game. That's how a neural network learns. So, these are the steps we will follow to train the neural network. The input data moves layer by layer with each neuron performing the weighted sum of its input, followed by an activation function. Next is calculating the loss. The difference between predicted and actual value is computed using a loss function. For example, mean square error or cross entropy loss. Third one, back propagation and optimization. The error is propagated backward like this to adjust the weight using gradient descent and optimization algorithms. And then training iterations. The network learns by updating the weights iteratively over many epochs until it reaches optimal performance. So now we have seen the basics of neural networks. Now we will see what is the math behind each and every step. So for example, you assume this as the neural network what we have built. So in that, this x1 and x2 are the input nodes in the input layer, and these three are the nodes in the hidden layer, and this is the output layer. So the input layer contains only the input values, whereas the hidden layer contains the weighted sum of input and the activation function. And similarly, the output layer also contains two parts. One is the weighted sum of the uh, hidden layer output. Along with that, you have the activation function. So each round in the node will look like this. One part is the weighted sum of input. Along with that, you will have the bias. Another one is the activation function. It will tell you whether how much priority that has to be given for this particular node. So first we are using some basic mathematics for making prediction. So this part is nothing but the linear transformation. So Z is equal to W1 x1 plus W2 x2 etc. up to Wn xn plus B, that is the bias. X1 x2 up to xn are the inputs and W1 to Wn are the weights. So and Z is calculated as a linear transformation of weighted sum of the inputs along with the bias. After that, we will apply some mathematics on the activation function. So either we will use the sigmoid function, that is 1 divided by 1 plus e power minus x, or we will use a ReLU function, which is f of x is equal to max 0 comma x. And then third step is calculating the loss, that is measuring the error. The difference between the predicted output y cap and the actual output y is measured as loss function. For example, mean squared error MSE is used for regression problems, where L is equal to 1 by n summation yi minus y cap whole square. And then for classification problem, we use cross entropy The formula is L is equal to minus summation y log y cap. So, in the next step, we are performing back propagation. That is, we are learning from errors. To improve prediction, we update weights using gradient descent. So using calculus, we compute the derivative of the loss with respect to each weight. Dou L by dou W is equal to dou L by dou A into dou A by dou Z by dou W. So this will tell us how much each weight contribute to the error. So using that, we will use the gradient descent which we have calculated in the previous slide to adjust the weight in order to reduce the error. So W is equal to W minus lambda dou L by dou W. So here lambda is the learning rate which controls error at each and every step. So just like how we improve through practice, a neural networks get better through feedback. If it makes an incorrect guess, so for example, the O is an incorrect guess. It adjusts itself by propagating its error backwards so that the weight at the intermediate computation is get automatically updated. This process is called learning or training. Over time, it gets better at recognizing patterns and making accurate predictions. So, the process repeats for many iterations. We call each iteration an epoch. That is, the forward propagation, loss calculation, backward propagation, and weight updation. So next we will see the different types of neural networks. So the image lists the various types of neural networks. So first one is the feed-forward neural networks. This is the simplest type of neural network. Data flow in only one direction from input to output. It is used in basic classification and regression tasks. Second one, multi-layer perceptron, a type of feed-forward neural network with multiple hidden layers. Use activation function like ReLU or sigmoid. It is commonly used in deep learning application. And then convolutional neural networks. It is specialized for image processing and computer vision tasks. It uses convolutional layers to detect patterns, that is, edges, textures, etc. It is found in facial recognition, medical imaging, etc. Next one is radial basis function. It uses radial basis function as an activation function. It is good for function approximation and time series prediction. Next one is recurrent neural networks. It is designed for sequential data like text, speech, and time series analysis. It has memory which stores past inputs using loops. It is used in language modeling, speech recognition, and more. Next is sequence to sequence modeling. Yes, it is a special type of recurrent neural networks. It is used for translation, summarization, and chatbot application. It uses an encoder-decoder architecture. And then modular neural network, a system of multiple smaller neural networks working together. Each module handles a part of the task used in complex AI systems like robotics and autonomous vehicles. Next we will see some of the real life examples where we will use neural networks. First one is voice assistants like Siri, Alexa, Cortania are used to understand your voice and respond. Second one, the recommendation system. So when Netflix or YouTube suggest a movie or video, they use neural network to figure out what you might like based on your past choices. And then image recognition. So Facebook photo tagging system uses neural network to recognize faces in photos. So why are neural networks so powerful? Neural networks are good at finding patterns in large amount of data. The more data they get, the better they get at making decisions. They can identify complex things that humans might miss, like subtle patterns in a photo, or predict things based on lot of past data, like predicting stock prices. In summary, neural networks are like computer brains that can learn from examples. They are made up of neurons arranged in layers. They learn by looking at lot of examples, making mistakes and adjusting to get better. They are used in lot of things like recognizing faces, understanding voices and making recommendations. Thank you.